Hey guys, welcome to Programming Knowledge. In this video, we'll be looking at classes in C++, but before that, let's first discuss a small concept which I had missed in the previous video. That is how to use pointers when using such collective data types. Here, if you see, we have the student structure which we had defined in our previous video. I have just added one single function to print the details of a student, and here I have created a student with the name Tony, age 10, and then the marks of these things. Now if you want to create a pointer, it's just similar to the way you do for a primitive data type. You just put star ptr and then you put ptr equal to the address of the student. Now if you want to access a particular feature, because in primitive data types we did not have features, right? We just had data. So if you did star ptr, this was enough. But in case of a object, we have so many features. We have two functions and then we have three variables. How do we access these things separately? Well, star won't work here, and we have a special operator known as the arrow operator. Well, what this does, this basically allows us to access separate features of an object, and the way you define arrow operator is by using a minus sign and this greater than symbol together. So if you combine them, that looks like an arrow. So that's from where the name comes. Well, if you want to use it, you just say ptr, that is the name of the pointer, the arrow symbol, and then the feature you want to access. So let's say I want to access the name. So if I just put name and then execute this, I'll be getting a name over here. So age also works the same way. If I just put age and then try to execute this, I'll be getting the age. And if I want to access some function, let's say the average function, I can just do that from here. So if I put average and then call that function, I'll be getting the average over here. So that's how you use pointers. The only difference is that instead of star, you are now going to use this arrow symbol. And this is a very important concept, as we'll see in a minute. This we'll be using a lot when using classes. So now let's dive into classes. Well, the way you work with classes and structures remain the same. So if you want to change this definition to a class definition, you just remove the structure keyword and then put class over here. So this now becomes a class. Well, the dot operator and then the way you work with pointers, this arrow symbol, all these things remain the same. So you don't have to do anything. So now let's do something like student dot print details. Now if we try to execute this particular function, we will be getting an error. So let's see what that is. It says that this particular name is private. Well, if at all there is any difference between a class and structure, that is this thing. A structure is public in nature and then class is private. Well, this is not a big deal. We can change public to private and private to public. We'll just talk about that in a minute. But what is public and private? Well, in object-oriented programming, when you're creating objects or when you're creating such collective data types, we don't want everything to be accessed by the outside agent or the user, let's say. So if we are creating a student data structure, and the purpose of this particular data structure or this particular object is just to store the details and then show the details, then you don't want the user to manipulate the details, right? So if I give the access of this marks to the particular user, he can manipulate the values inside, right? So same with the name and age also. So if you don't want some of your features to be public in nature, that is, you don't want some of the features to be accessible by the user, you can put them in the private section. So how do we put that? You just need to put private over here and put a colon over here. So in a class, everything by default is in this particular definition. So if you want to make a structure into a class, you just need to remove this class and put structure over here. Now this particular entity is just like a class. You will be getting the same error when you executed a class. And if you want to create a class into a structure, if you want to change a class into a structure, what you just need to do is you need to change everything to public. Now if you change it, you will be getting the output just like we got in case of a structure. So that's why I told there is no difference between a class and structure. Although we don't use such access specifiers, these are called access specifiers because they are specifying the access of these features, right? So we don't use them in structures. That's just by convention, you can use them. There's no restriction on that, but we generally don't use them. We just use them with classes. So can you have multiple access specifier inside a class? Well, you can. So these just define different features to be either public, private. So there's one more thing called protected, which we won't be seeing in this particular video because we'll better understand it when discussing about inheritance. But for now, we'll just discuss about public and private. So as I told you, these things become private, and I want only the print details function to be public, so I'll put public over here. So whatever is below private becomes private, and whatever is below public becomes public in nature. Now I can access print details without any issues, but I cannot access all these things. Then how can I actually create an object with these features? That is, I want the object's name to be Tony, age to be 10, and marks to be these things. How do we do that if I don't have the access of this variable itself? Well, for that you can define another function in the public section. You can say something like void set detail, something like that. These are more specifically called setters. These are called setters, but setters are used only for a single variable. So if you want to assign variables at a time when creating the object itself, you generally use something called constructor. Well, constructor is basically a special function which is used to create the memory when you're creating an object of this type. So let's say you're creating an object of this class student, you need memory to hold these three variables. So constructor takes care of that particular memory requirement, and you don't have to explicitly define a constructor, although you can. And many people use constructor to assign variables when you are declaring them. So in our case, we are declaring these variables, right, which are private in nature. So in case you want to declare them while creating, you can either use a setter function, or many people just use constructors for that. So the way you define constructor is, it doesn't have a return type, so you just need to omit the return type. You should not give any return type, and then the name should be the same name as the student. So over here you have student as our class name, so that should be there. And then you will just define it just like a normal function, and here you can pass in parameters and all. You have different names for that. So if you have a normal constructor definition like this is called a general constructor. And then if you have parameters inside that, let's say string name and then int age, so this is called a parameterized constructor. There are different names, I encourage you to look that up. But for now we'll use this particular parameterized constructor, and here we'll pass in another variable, the marks variable. And now there is an issue. If you see, the object's attribute or the object's feature called name is clashing with this particular name. Well, you can change it so that you don't have an issue like this. But as I told you when discussing the pointer just now, that's going to play a very important role in classes, and that is where this comes into play. This is basically pointer. It is called this pointer only. So if you just put this, you can see that it is bold. It indicates that it's a property of the compiler. It's a reserved keyword. This is basically a pointer which will point to the current object itself. So let's say I have 10 students, and then I'm working on the 7th student. So if I use this pointer, then I will be accessing the 7th student details, not any other student details. So this basically points to the current object which is getting used, and then we use it just like we did in case of our own pointers. So this, and then this particular arrow symbol which is called the arrow operator, and then the variable name. So name equal to name. You could say this age equal to age, and then this marks equal to marks. Well, if you don't want to use this particular definition, you can always rename this and this won't be an issue. But just to explain the importance of this particular pointer and this arrow operator, I just took this particular example, but you're free to use whatever way is convenient for you. Many people tend to use this particular definition, and here when we are creating, you just need to pass in when creating itself. So here if you put parenthesis and then pass in your variables, so name equal to Tony, and then the age is something 10, and then the marks, well, you need to create another variable for marks, so marks, and we'll push back all these things inside this particular new variable. You don't need s over here because this is an independent variable now. We just created a new variable in our memory, and here you just need to pass in marks. And now if you just remove all these things, this should work as expected. So if you now run this, you will be getting the output just like we got in the case of structures. And now you have successfully implemented an object oriented design. So something is private, something is public, you are not giving access to everything, and all these are basically features of object oriented programming. So now let us see another very important function, which is a special function called the destructor. Well, this is not used much, but since it's a part of object oriented programming, we'll discuss it quickly. It's basically the same thing as a constructor. It is defined by the compiler itself. It's a default thing. A destructor, what it does is it will scrape out the object from the memory. So if you're running out of scope, so let's say we had defined this object inside an if block. So once the block has been executed, that variable is out of the scope, right? So once anything gets out of the scope, it's going to be scraped out of the memory. So that's when a destructor is called. So if you want the destructor to do something else, you can just do that by putting this type symbol, and then you define the destructor with the same name as a class. And again, you don't put any return type for the destructor, and it does not even take any parameters. So you cannot pass any parameters to the destructor. You cannot call the destructor from anywhere. You can just see what it does. So if you just call this destructor, let's say I'm being scraped, something like that, you will be seeing this when the object gets out of the scope. So we'll just put something over here. If some condition 10 equal to 10, this is going to be true, so all these things will be executed. And over here we'll put something like done. We'll put a new line also so that we can differentiate. So if you now execute this, you will see all these details, and then it says I'm being scrapped and then done. That is because once the if block has been executed, that particular object has been removed out of the scope, that then it should be ready to be removed out of the memory too. So just remove that thing from the memory. That's why this message is printed. And then you have this done, which is outside the if block, which indicates that this has been scraped before coming over to the statement. So that's the use of destructor. If you want to see when the object is getting removed from the memory, you can use destructor. We'll again talk about this when we are discussing about inheritance. But constructor is mostly used to actually pass in parameters when we are declaring a particular object, something like this. So now, how do most people use classes in C++? Well, mostly people don't use classes in the way we used over here. We wrote the class definition and the main function, everything in a single file, right? So people generally don't tend to do that. People generally use multiple files in their program. So you have one particular file only executing the main program, and then you have multiple objects, so you don't put all the objects in a single file. You create multiple files for holding the objects, and then if you want to use this particular class, let's say the student class, you just include it just like this particular vector. So what you do, include, and then you put the student over here, student dot h, that's an extension. We'll be saying how to create this, and here instead of angular braces you need to put this quotes. So this indicates that this is something from this particular directory and not from the compiler. So these things are available in the compiler, that's why we are putting this angular braces, and here you are putting this to indicate that this is from this particular directory or this particular project. So you have two files when declaring such classes. So what to do is you have one header file where you declare the skeleton of the class, and then you have one CPP file which is just like this one, which will hold the definition of this class. So how do you separate that? So let's say I want a particular function to be defined in a separate file. So let's just say this particular function called to be defined in a different file. So how do we do that? You just need to put a semicolon over here. So this is just like a function prototype which we had discussed. And let's assume that this is another file, so this class is in some other file. You just did something like hash include student.h, and then if you want to define this particular function, the way you do that is you just define this function normally as though this is just a normal function. It doesn't have anything to do with this class. You just defined it. So let's say uh, I'm called and something like that. You just define it like this, and then over here to define that this particular function is specifically designed to this particular class, or this function should be available only to this particular class. What you do is you just put in this particular class name, and then you put two colons over here. So this will indicate that this particular function is to be used only with this class, that is the student class. Now you cannot use call directly, you need to call it using the student class. So if you want to use that, so you can say something like s dot called, and it will work normally. So that's okay. We don't have the student.h right now, so we don't need these things also. So if you run this, okay, there's another typo over here. Okay, so here you can see I am called, that is from this particular function which we just defined, that this called function over here. And here this is the message from the destructor, that is I am being scraped. So that's how we actually use classes. But this particular id, which is the code blocks id, provides a easier way to create classes. You don't have to define all these text. That is, you don't have to create two files and then put them. It will neatly organize everything and give it to you. So how do you use that? Well, you go to file, you go to new, and then you create a class over here. So you have class name, so you just give some name, let's say student. And then here in place of arguments you just leave it, so it has hash destructor, virtual destructor, all these things. You don't have to understand all these things right now, you can just ignore them, but we'll understand what all these things are in later videos. And now if you just click on create, you can see that the new class has been created. Do you want to add it to the current project? If you just say yes, and then you just put ok over here, and then you will see that in headers you will have an include folder inside which you will have student.h. So here if you see, it just has the definition. Let me just increase the font size. Here you can see it just has a definition. You don't need this. This is basically the virtual destructor. We'll talk about that later. And here you have a constructor, and you have protected and private. You don't need protected also. As I told, we'll be discussing about that when we are discussing inheritance. And you have some special commands over here. So what this roughly means is that once a particular class has been included in the memory, and if it's again trying to include it, you don't do that, because we are using two files. So let's say I'm using a function from this particular file. So when I don't want this particular function to again include it, so here you can see hash include student.h. So when I'm doing it multiple times, I don't want this particular class to be loaded into my memory multiple times. So this particular guard block, as it's called, this is called a guard block. What this will do is it will take care of this particular issue. It won't allow this class to be included in the memory multiple times. And here you just declare the skeleton. So here if you see, if you want to create this particular class again, we'll just create a small version of that. So it will just have a age, let's say int age. And in public you will have a setter function. You will just say set age, or you can just directly use it inside over here. So int age you can just say. And private, I prefer private to be in the beginning, but it's up to you. The order doesn't matter. I just put private in the beginning and then public at the end, protected in the middle. So that's how I use classes, but it doesn't matter, you can use it the way you prefer. And now you just need to define this constructor in the student.cpp file. We don't need this virtual constructor, I just deleted that. And here you just define it normally. So age is something private, but you can access private variables inside a class. So you can say something like this age equal to age. And here, if you want to use this class, let us just remove this class because I've already defined it. So remove this. And if you want to include that student class, you just say hash include and then student.h. And now all these things work fine. Well, we don't have everything over here, so we need to redefine it. So let's quickly do that. Student s10. And if you execute this, what do we have here? It says, yeah, because we forgot to put the parameter over here. It is int age. And see, we did not get any error. So that's how we generally use classes. If you want to create another class, go here, new, and then class, and you can create another class. So people generally tend to use classes like this. You have neatly structured thing over here. So you have a main.cpp over here, and here the student.cpp goes inside the source file so that you don't get confused. So everything, the header files which I talked about, the student.h or anything class, header files are basically class name dot h, and all these things go inside this include folder, and the definition file, which is basically class name dot cpp, all those things go inside the source folder, and main file will be outside. And you can use that main file to execute the program. Everything starts from the main file, generally name that as main.cpp, where the execution starts, and we include all our objects like this using this particular syntax, that is, you pass in the class name .h file using this particular codes. And the guard block which we just talked about, this one, this basically takes care of multiple allocations of memory of this particular class. So that's all about classes. In the next video, we'll make another one of our projects. So our previous project was the tic-tac-toe game. Well, we'll again make another game in the next video because I think games are fun to make and then we can learn a lot from them. So in the next video, we'll make another game by using all these concepts of object-oriented programming. Till then, happy coding.